Hello guys, my name is Diego Pacheco and this video will be a slide cast. So I want to talk more about troubleshooting, about debugging, and about fixing mysteries. Sometimes it can be pretty hard, but also pretty entertaining to deal with some issues that we might have a hard time to figure out. So basically today I made a slide cast, so let's get started. So I want to talk about code forensics, right? That's the name of the presentation, and basically we will discuss some investigation techniques. So let's get started. So my name is Diego Pacheco. I am a cat feather. I am a software architect. I am a SOA microservices expert, a DevOps practitioner. I wrote the book Building Applications with Scala. I record the series Building Effective Microservices with Java and Netflix OS Stack. Here's my GitHub, my Twitter handler, my blog, and also my YouTube channel. So the agenda for today is, let's start with some don'ts. So things you should avoid at all costs. Then let's talk about how to run an investigation, which is pretty much science 101. Then let's discuss some tools and some tricks to help us, like observability, like debug tricks, like Linux tools. And finally, let's talk about how we should close the case, meaning some important activities like postmortems, RCAs, and retrospectives. So first of all, let's start with don'ts. When there is a crime scene, basically the police goes there and put these tapes and say, "Do not cross." Because you might contaminate the crime scene, right? And you might, prevent the police to understand what happens there, right? So let's talk about some don'ts. So first thing, do not freak out. Easier to say than done, but that's true. Because if you need to avoid to add some extra pressure on yourself. You need to avoid worried about time. You need to avoid making comparisons like, oh, this should be done on 1 hour, or maybe my fellow workmate might be doing this in 10 minutes. As time passes, it's very easy to freak out, right? So you need to calm down, drink some water. It's important to stay calm. Otherwise, you're gonna have two issues to fix, not one. You need to keep in mind that making progress is your friend, right? You might not close the case if one single step. Sometimes is a series of theories and things that you investigate and test it, but you need to keep in mind that making progress is actually what matters most for this kind of difficult issues. Your eyes can easily trick you, so you need to use tools, and I'm gonna talk about some mindsets you really need to have later on this very presentation. And you need to make sure you are doing things properly. If you are comparing strings, it's easy to miss one character and things like that. If you are hiding errors, the exception in itself might be 90% of how you can fix the issue. So you really want to read carefully, read multiple times. It's not a shame to read 3-10 times the same exception. You should really write things down and use tools, all right? You need to use tools. We're gonna cover some tools later on, but be careful so your eyes do not fool you. Don't forget to breathe. So keep calm and keep going. Second, it's really important, right? You might think this is silly, but this is really, really important. You need to stop doing many things at the time. So do not do two things at the time. As you are investigating, you might have this hyperflow of ideas and things you want to try out, right? That's maybe you are anxious to get this done, so don't, right? You might want to change the code, variables, from operational system, config files. You want to try different things. Slow down, all right? Do not do many things at the time, because you can only have one hypothesis at the time, right? And you need to be very nailed down to small things, because if you do many changes, right? If you change the code, you change the database, you change configs, you change some parameters in Linux, how the heck do you know what exactly made what, right? So you want to be reasoning about what's going on, right? That's why you need to do things easy and slow. You need to be, and that's like the mindset, right? Is the crux of it. You need to be methodical, you need to be boring, and you need to be slow, right? So write things down, do one thing at a time, check things, breathe. That's really important mindset to fix stuff, all right? It's very easy for us to miss things, and if you're just clicking like crazy, you're not paying attention to what's going on. You need to be slowing down. That's super important. Now let's talk about how we should run an investigation, right? And first thing you need to talk about is Science 101, because it's all about science. In the end of the day, this is code forensics. We need to also work in ways to minimize the investigation efforts. We really should have theories. We really need to write down facts. It's also important and a good practice if you can have a partner that can do pair programming with you. It helps a lot. So Science 101, all right? So in the heart of it, this is science. So you need to start asking questions. So first thing you do, you ask a question. Then with that question, you form hypotheses, all right? And with that hypothesis, which are pretty much assumptions, right? You think that could be the issue. So you have experiments, and then you want to observe and record, meaning writing down, all right, the results of that experience. Then you can draw conclusions and share your findings. And this cycle may repeat. That might lead to the next hypothesis, and so on and on and on. All right. That's also, some tangent here, how lean startup works. All right. And how discovery for products work. They work all in the same way, because it's all about science. Right. So that's in the heart of what we need to do. That's what we're going to be doing. However, starting with it might be hard, right? So first thing is ask a question, right? But I don't know what question to ask. Well, then we can start looking for things to see what kind of questions will be interesting to ask, all right? Because you don't want to ask questions that are not relevant, right? So you want to nail down, you want to reduce the possibilities, all right? And there are some things you can look for to help you this narrow down, all right? And this narrow down, you can also be seen as the crime, right? So the crime in the code might manifest, like your dead body in different ways. Like if it's a Windows desktop application, you might have a crash report. If it's a website, you might get a 404 or some error page. If this is a test you're running on Eclipse or IDEA, you might see some test report, some surefire report, something like that. If this is a C application, you might see some core dump that you can GDB and figure out what happens. If it's a Java program, you might see some stack trace somewhere. right? And that's the place to start. That also can be called, I have a friend of mine that always says the smoking gun, right? So that's the smoking gun, or that's the bullet, all right, that killed the victim. So that's what you need to look for. Often, what's there, or what's the stack trace, what's the proof that we have a crime, okay? So that's the first thing. So, and once you get there, read carefully, and then we're going to start asking questions. So what questions should I ask? Well, basically, for instance, on this image, we can see there's a null pointer, right? So how I got this null pointer? Well, probably some variable is null because maybe there's a corner case, maybe someone forget to inject a spring bean there, and then you can start having theories and check these theories, right? And then you enter on the science. It's really important to further isolate the possibilities, because let's talk about the real crime scene, right? So let's say it happens in a city. I am in south of Brazil, right? And Porto Alegre is a big city. So I cannot go to every single house in Porto Alegre and ask everybody if they saw the murder, right? If they listened to anything, right? And let's say there's a shooting that happens, it's not likely that the whole city will hear it or know it about it, right? So we need to have some kind of perimeter, right? And that help us, because if you think about a code base, you have a digital product, your code base might be huge. You cannot go and look every single class from your code base, which will be the same as investigating and interrogating every citizen on a city. All right, so you need to make this perimeter. So there is this interesting book I'm gonna mention when I go to the references, all right, that talk about code and a crime scene. And there's this small talk application called Code City, where it builds a module using a tool called Plasma, and then with Plasma module you can import on Code City. And then what happens, it creates a city, and this city is the graphical representation of your program, of your code. And what the city wants to show, right, what wants to prove is the skylining, right, is the skyscrapers, is the big buildings that matters, because these big buildings on the city are basically hotspots, which means these are big classes, or they are classes that are having many changes, right? So there's two ways you might find these hotspots, either by lots of commits or Jira tickets on that specific part of the code, or basic because it's a very big and long code, so therefore is a hotspot. And you might be wondering, what's the relationship with that, with the crime itself, right? Well, this book, Code as a Crime Scene, says that there is a relationship, right? They did a research and they found out that 4% of code has 72% of defects, right? So they found out there's a huge relationship between code hotspots and bugs, all right? And it kind of makes sense, right? Because if people are touching that code a lot, or that code is very big because probably is complex, all right, definitely that there's a good chance that the bugs will be there, all right? And that might be helpful for you because it can help you to narrow down your search. And if your exception is nearby the hotspot, there you go. Then you can further reduce the blast radius, all right, the investigation radius. And that's an important thing to do. Then you need to start working on your theories. So basically, this is like a guessing game. You need to think in your mind how the murder happened, all right? So how the application crashed, why I have a core dump or why I have a stack trace, why that happened. And you need to think on most likely things that could happen. So this is really creating theories, all right? There's some classical offenders you could think about. For instance, it's like making a profile of the murder, right? and then you're thinking, okay, so often it could be some null pointer exception, NPE, because lack of validation or test, is definitely a code change, because if it's failing, it's because someone changed the code. The interesting thing is it could be a recent code change, but sometimes it could be an old code change. It could be more than a year, because I don't know, it takes some time for your consumers to migrate to that specific version, or that branch, it took it some time to be activated. It's more likely to be a recent change, but it could be an older change, more than a couple of months ago, right? It also could be a config change, right? It could be some credentials change, some certificates, some users, some passwords, some IP, something like that. It could be a typo somewhere. It could be, in AWS, it's very common to have security group issues, right? Someone forgot to open a port. It could be that you don't have enough resources, that, you need more memory or more space. It could be some out of memory, right? But for each of the theories, here you have some ideas or what the offender could be. So for instance, let's say if there's a OOM killer, right? Okay, so I expect to see heavy usage of memory at some point. So probably if I look some chart, I'm gonna see that the memory was high, or in Linux kernel, probably gonna see some OOM indication there. If I cannot find these things, if the memory was never high, so then was not a OOM killer, and that's how you go. You create this theories and you try to validate your hypothesis. When you're doing that, it's really important to write down facts, right? So you can write down in paper, text file, Evernote, Google Docs, whatever. It doesn't matter, right? You want to write down important facts. So like, what's the theory you're trying to validate, some case information like class names, methods, variables, this kind of stuff. You want to make sure you don't get lost. You want to make sure you don't validate same theory over and over again. You want to make sure that you are being methodical. You're not losing anything, because it's easy to forget information, right? Because you're worried to fix the bug, you want to move on, right? So that's why writing down facts matters. Then let's talk about having a partner, right? Having a partner can help you a lot, right? Because having an extra pair of eyes can make this a much more secure investigation. There's some studies that says that pair programming definitely gonna make you slow, right? However, they also prove that you're gonna make less mistakes. And in the investigation, you really don't want to make mistake, because probably you could be with the solution right under your nose and you might lose it, right? And you don't want to do that, right? So it's really good to do pair programming. Pair programming has some additional benefits, right? Because you end up doing collective code ownership. You end up building this knowledge sharing culture. You can have two people thinking different things. You can do reflection. You might also use the debugging opportunities to understand more how the system works, but also to figure out if the design is right or wrong, if the code's well written. You might have some ideas for future refactoring, right? And that helps you to be focused. So pair programming, having a partner, has some other extra benefits. If you are having a partner and doing pair programming, it's important to do it on the right way, right? And you always want to do it like a rally. If you imagine like the Dakar rally, this kind of a rally, you want to have like a driver and a navigator, right? Where the driver is really worrying about typing, micro concerns like syntax formatting line by line, fixing the tests, and the navigator is more thinking in concerns, or right, macro concerns, right class effector algorithm, etc. However, we are doing investigation here, right? So the driver probably is conducing a debug, and the navigator is more looking for a theory and verifying the facts, all right? And that's how you can play it. Now, let's talk about some tools and some tricks, all right, to help you to do your investigation. So we will cover observability, debug tricks, Linux tools, and write your own tools. So observability is really important in microservices and distributed systems because pretty much you have so many things that can go wrong, right? So you want to have metrics, dashboards, centralized logs, and tracing. And these are all useful informations because they are like security cameras, they're like digital finger prints. These are all like DNA material. These are all evidence for the investigation. So you really want to take a look on the logs, you want to take a look on the charts, and that will make your investigation going better because you're going to have data that you can use to test your theories. I love this quote that says that debugging is like being a detective in a crime movie where you also are the murderer, right? So you are investigating and probably you are also the murderer. Here are some debug tricks, all right? There are some obvious ones like, take a walk, use breakpoints, look Google, this kind of stuff, read the docs. And also would say know your IDE, right? To know how to do remote debugging. Sometimes remote debugging really save you. Other times you can rely on some tricks for productivity. I have another video I made about some debug tricks on IDEA. You guys can take a look there. But there's interesting things like conditionals. You don't need to debug a lot to get to a specific point. You can write a condition breakpoint and go straight to it. You can have log expressions to print more detail if you don't have enough. You can do hand time evaluation, which could be really useful for you to test your theories and to verify things. Have exception breakpoints or field breakpoints. These are all IDE tricks that can help your debugging to be more productive. Another important set of tools are Linux tools. Linux has diagnostic tools for every kind of thing you can imagine, right? Like you can do a TCP dump if you want to check there's something with the network, right? You can do strace if you want to check something on the kind of system calls your program is doing, what's going on there, right? You can do LSOF if you want to check like the virtual file system and see open files, right? You can do netstat to see sockets, or if ports are really binded, it's someone really using that port. So I really recommend you to study and really study and use Linux tools. They really can save you a lot, right? Especially like netstat, strace, LSOF, TCP dump. These tools are super important. I also can argue, right, depending on what you are building, you wanted to write down your own diagnostic tool because they help you to narrow down the problem faster. You can pack these tools in kind of a single binary, like can write that code in Go or Rust, or you can have some program scripts like something like in Groovy, Python, Rust, or Go, where you can have this quick diagnostics and you make your life much faster, right? Because sometimes you don't have the tools on the machines, and then you need to get the tools there. If it's a remote program, even if you're in your machine, you probably want to get these tools there, right? So if you are building a library, you definitely want to have diagnostic tools for your library. Then it's also important to, when it's possible, right, because sometimes this is not possible, to compare with something else, right? Sometimes the bugs, they happen after a specific version. So let's say there's a framework, a library, or a solution that on the version 4 stopped working, but on the version 3 was working. Well, then you can compare, right? It's very likely the issue could be a code change, right? So if you can figure out, okay, if this was working the version before, I might have some clues on what changed. I might do some comparison. That's not always possible. Let's say you are building a new feature, but when it's possible, you can use diff tools like WinDiff. You can use GitHub, and you basically compare previous versions, all right, of the code base where you see the exception or the hotspots nearby the exception, or compare previous tests that worked with the tests that are not working right now. And then you can debug, write down the difference, and then make your theories, and you can try to understand why that crime happened or that bug in the case. So now you made the theory, you had a hypothesis, you test your hypothesis, and then you find the bug, you find the root cause, right? And now you need to close the case. So to close the case probably means, okay, let me open a PR and close this here ticket. Not so fast. There's some other things we should do. Often people are not doing this kind of stuff, and I think that's important, right? So before to fix, we need to share and we need to improve. And that start by adding more tests, because a bug just happens because there were tests missing. Otherwise, your test will be pointing out that crime, and you wouldn't be losing all this time doing this investigation. You also should be doing post-mortems, and a post-mortem, right, is a very common DevOps and SRE practice that sometimes engineers doesn't do much. I have experience in the past doing lots of RCAs, and that's an interesting practice as well. And finally, retrospectives are interesting tools. So let's talk about this a bit more, right? So first thing, you really need to add more tests, right? So that's kind of the Boy Scout rules, where, I was never a Boy Scout, but I love this rule. You basically, you leave the place, you left the place better than you find it, right? So you improve things. And closing the case, the first thing needs to be adding a test, right, to show that that issue happens, right? So we need to create a test to simulate the issue. After we investigate it, then that test will fail, then we're gonna have a proof, then we fix the code, that test will pass, we can commit this thing. It's also important to think about the test pyramid. Sometimes this test should be unit test, I would say most of cases, but sometimes it only has value if it's an integration or end-to-end testing. And we need to think about what kind of test we need to build there, right, to have the proper test. Otherwise, you might don't have value at all. Then, very few people do this for engineering, right? I think you should run a post-mortem session, right? And I love this picture because, DevOps SRE says that these things should be blameless, right? And you can see here inside of this door where the post-mortem is happening, outside of the door, you left all the blame, all right? And that is the idea, right? Before I describe what's a post-mortem and how you can use it for this kind of things, let me show you another technique called RCA. RCA is not that cables you used to put in your old video cassette, right? That's not the RCA I mean. So they're really similar to postmortems. They're lean tools. They can be used with other system thinking techniques like 5 whys, fishbone, and any other system thinking tools, right? You can have like an Excel file where you can have an issue, some classification, why it happens. You should have discussions, right? And how we make sure this doesn't happen again. Often the difference between postmortems and RCAs are they're pretty much like the same idea, but I see more like a DevOps and SRE, more infrastructure folks doing postmortems, and I see more engineers doing RCAs, but they're pretty much the same. For postmortems, often you have like a timeline with times and events, so describing what happened, and the fix sometimes could be in one system, other times could be in several other systems. For RCAs, it's easy to say, okay, the fix is just to add a test and that's it, right? But it's important to have discussions because, of course, you added the test, but maybe that's a clue that you are missing a diagnostic tool, or maybe it's a clue that your design is not good enough, or maybe it's a clue that your code review is not working well. So you really want to investigate not only your case, but other cases together to maybe spot some other trends, right? Because that issue might be, so let's say there's a neighborhood having too many crimes. Maybe you need more police there, or you need more social work, or you need more jobs, or so it might have a different systemical issue. So, and that's true for the code as well, right? That might be an architecture problem. It might be a process problem that's leading to this kind of behaviors. That's why you really should be reviewing these kind of things. And that is the relationship with retrospectives. Often people do not talk about these things in retrospectives. People fix bugs, but often people do not talk about the bugs. And they're losing very important opportunities to improve things on a small scale, like sharing investigation techniques, code as crime scene and this kind of stuff, sharing understanding about the system, but also sharing big trends, right? Because probably if you have lots of bugs happening, there's something else which is the problem, right? Often this is a systemical thing. And like I said, it could be your code reviewing process, it could be you missing tests, it could be your architecture, it could be a bunch of things. It could be that your talent pool is not good enough, etc. So you really want to discuss your issues, all right, to improve the system, and that's really goes beyond the investigation, right? Unfortunately, so few teams do this kind of techniques and practices, right? When I do retrospectives, I used to print out all the RCAs and show to everybody and have discussions and try to spot major trends, all right, to improve the team as a whole. And I think that's a super important exercise. You really need to do it, right? So finally, I want to share some books. Your Code as a Crime Scene is a very amazing book, and also Software Design X-Ray. These are both books by Adam Thornhill, who did a very interesting job, doing this kind of metaphors. Also working with effective with legacy code is really important because legacies are everywhere. Every company has a legacy. Thinking in Systems by Donella Meadows is a really amazing book about system thinking, which, in the end of the day, investigation and these issues, they're really systemical. They are related to other things, so it's really important book. X-Unit Test Patterns, it might help you with your unit tests after you fix your problem. And System Performance by Brandon Gregg is an amazing book about Linux and about cloud and about troubleshooting. It's really interesting book working with the cloud and can help you. It doesn't matter if you are SRE or DevOps or engineer. That's interesting. So that's the books I recommend for you guys. So that's it. That's my code forensics presentation. I hope you guys like it. See you next time. Bye.